Thank you for being here. I have a lot of free space at the beginning, so this is the death row, probably. I'm joking. Anyway, hi, hello, hi to the stream. So we're here to talk about making Node.js performance profiling actually work. We're going to go, I don't know, hopefully I have a demo at the end. We'll see. And I have a few slides. So hi, who I am, hello. I'm Matteo, probably you know me. If you don't, doesn't matter at all. Part of the Node.js Technical Steering Committee, board member of OpenJS, board member of GraphQL Foundation too. So, and CTO of a startup called Platformatic. Hello, I'm here. Created a bunch of libraries that you all use, and more importantly, you're downloading my stuff 30 billion times a year in 2024. I'm probably going for 50 in 2025, so we'll see. Okay, it's, I don't know. You're using my stuff. So we're going to talk about Node.js, and specifically, we are going to talk about profiling. Now, the Node.js guide for profiling tells you to do this, node-prof, and you pass in an app. And it gets you some, and then you need to do --perf process to understand what that does. And this spits out something like some text like that, which is not useful at all. In fact, there is a very nice long profiling guide that states all the steps to do this. And this is a quick, short video on how that works. And you can see that it's not really useful. I was discussing recently with somebody who says, no, but this is useless. Like, how does people do this in practice? Okay, and this was look at how long this is. And still, it doesn't tell you anything. Now, at the end of it, it just shows maybe something, but whatever, like, oh gosh. OK, this is not worth doing. OK, all of that is not really useful. So more importantly, though, you can't easily run it locally or even in Docker, which is even worse, because that's when we want to know how it's going. OK, we want to be able to run profiling in production, if possible. OK, so anyway, it's hard. So anyway, this process is not really an old problem for me. Okay, back in 2016, myself and my friend David Mark Clements, you can understand this was a few years back because all my beard was still colored and there was no white. Okay, we started working on a library called 0x, on a module called 0x, pretty cool, long time ago. Okay, 2016. And which has a nice logo, by the way. You can still use it, it still works, and it's still a good piece of library. So you can, can help solve some of the problems that you have seen. But it has more challenges. So anyway, 0x can use a few different ways to profile your application. It can use dtrace and perf. What are dtrace and perf? They are lower level kernel techniques. So it gets you the profiling data from the kernel. The benefit of this is that it has almost zero overhead. The problem of those is that they require almost root level permission, and you can't run them in Docker, more or less. So good luck. Okay? However, you could get the profiling data using the V8 inspector protocol, okay, which is what you are using with the Chrome DevTools, essentially. However, it has more or less 100% overhead. But you can run it in Docker. So what do we do? OK, this doesn't look good. OK, so by the way, why is the inspector protocol so slow? And there was a nice snail that I need to put in this picture. OK, so why it's slow? Well, the way it works, if you want to use your application to capture using the inspector protocol to capture your app, is first of all you need your application start. OK. And when your app starts, you can inject some preload code that open the inspector port. Okay. Then your preload need to start profiling. Okay. And then after it's done, you need to stop profiling and download the profile. Now you see, I have the inspector running on my process. I have it open a port. Then from the same process, I connect to myself to download the profile. Does that look a lot of overhead to all of you? Maybe yes. So that's why it's slow. OK? Our friend at Datadog, OK, hello, hi, Datadog friends, created this library called @datadog-pprof as an alternative. Instead of doing all that dance with the port and so on and so forth, it uses the same underlying C++ APIs that is used by the inspector protocol to implement the same feature. Okay? How does it work? Well, you can just call it and it will just do the job. Okay? And you can download the file and so on and so forth. It's very straightforward. You don't need to, it doesn't do all that dance. It's also very, very low overhead. What's the overhead? Well, it's very little, okay? Like, let's consider this. I just wanted to show you because let's see that with just an health check, it has a profiling enable. With profiling, it's a little bit slower, but not much, okay? But the moment you just move to high computation or mixed, it's not a problem anymore, okay? It's completely disappear. So you can essentially run your application with this enabled all the time. And this is actually how the Datadog agent does it for you when you enable the continuous profiling on them, okay? Pretty cool, right? Perfect. So with this, we can profile the app. Cool. It emits a file called the extension pb.pb. It's a gzipped blob of binary. What do we do with it? Can I use to debug or profile my application? No, it's useless. Okay? It's just binary data. Okay? We needed a way to visualize that thing. Okay? How did we find a way to visualize the thing? Well, we had to create something because there was not really a good visualizer for it. We created this library called react-pprof, which is a React component and then a CLI tool generically to help that you can use to help to visualize those components, those files. Now, react-pprof is just built as a React component, so you can take it and plug it in your dashboard if you want to do that. So it's really like, that's why we built it in that way. And it's how we use it. So I'll probably later show you up how we use this component. So anyway, this is what it does. There's a few nice features. First of all, it's built on WebGL. Why WebGL? Because it's super fast. Those things could create, doing a flame graph for big live applications was a big, big problem, okay? Ooh, okay, sorry for this. Why it didn't, sorry, of course, it happens. Okay, happily. Okay, so we have the WebGL rendering pipeline. Okay. Why it's a problem? Because in DiroX, rendering very large flame graphs was problematic because of the large number of divs and elements that compose the flame graphs. So the bigger those flame graphs were, the slower they were. And to be honest, I've seen multiple times Chrome just crashing and giving up when rendering the flame graphs. So you couldn't do anything with it. Okay. So there is even that problem. So we needed something very fast. So what we did, we wrote it using WebGL. Comes with some complexity, but yay, it's there. Then we also had some accessibility and we had some responsive design and so on and so forth. And we implemented a full, like all of these is just all the best and brightest of the testing you can do with some visual regression testing, those kind of things that, how you should write components ideally, okay? Anyway, what's missing though? Memory, okay? One thing that module at Datadog/pprof does, it also now enables you to collect memory data and a memory profile of your allocations to respond to the question of which are the functions that allocate the most data. Pretty good, right? Okay, so it actually does that too. So you can even get that kind of information for memory, and you know where that will show up. Okay, this is an example. We changed it, we picked a different color scheme for memory. So for memory, you can show it in a nice purple way. Okay, it's good. OK, so we have the library to get, we have the library, and we do have a way to visualize the data. What's missing? Well, the developer experience is missing. How do I combine the two things together? OK, so we created this little tool at Platformatic/Flame to combine those two things. OK, it's just a CLI utility. It's very straightforward. You can just use you install it, and then you can just use Flame, run your server, and then it just runs and generates those outputs for you. Also, you can even turn on manual mode. With manual mode, you can just start and stop profiling, sending a signal. OK, so magically, you can control this even from the outside. OK, if you want to. Oh, I can SSH into my kubectl pod, start profiling, and then stop profiling. OK, even that is possible. If it's not enabled, it does not add any overhead. So pretty cool, right? So do you think we can run it in production? Well, there is missing a few things. OK, in order to run it in production, we're missing a few things. So we are missing what we call essentially a frame graph controller in place. OK, you need somebody that should, it's a daemon running somewhere that you should put to, that it should be there to orchestrate those things. First of all, you could, the flame graph controller could just send down a command to the app and said, please start profiling your app. Good. Another thing is that is a command that can go down, and your app can send up the pprof data whenever it needs. So the other part is about self-detecting when to send out those profile data. It's for one thing is we could essentially start capturing that data and send up a profile when your application, when we detect, for example, that the event loop is blocked, or there is some other, there is a high traffic situation. Okay, there is some threshold, internal threshold that is matching. Why is this useful? Because the moment I self-detect that the event loop is blocked, I can and start doing this kind of work. I can essentially notice very early what are the problems and what is causing problems in my app. Again, all of these is all ideas. I just wanted to show that with this piece you need to, it's not built in. Okay, this is so far so good. We are missing this piece. Okay, so how do we ended up fixing that part of the problem? Well, a few months back, a year ago more or less, we released this component, VAT. Is an application server for Node.js, which you can use to orchestrate those kind of flow. These runs can run your app, and it has embedded flame graph capability. And then how does it work? Well, we have the VAT application server allows you to run multiple Node applications together inside the same process as threads. OK, pretty good. And it works for Next.js, Node, whatever, Express. You can have what you want. Then on top of this, OK, we have created something called the Intelligent Command Center, still open source. It also has a commercial version, whatever. And this is your flame graph controller, OK, that I described before. So how does it work? Well, we have the Intelligent Command Center, OK, and we have their application running VAT. OK. Now, this is VAT, your VAT instance. Let's say that you have an auth service that receives some some JWT messages, a post to verify JWT. OK. Now, those are crypto-based activities. Those are very slow. So it's your system essentially starting to go on fire. So immediately it can send an health signal and the flame graph data to the scaler. Similarly, we have the auth service, and similarly we have the logic where the Intelligent Command Center send out a command down to the app and tell it, please send me the flame graph data for that specific component, for that specific application. Again, similar logic, but there is a command going down. Okay, for why you could ask why we are not sending that data all the time like Datadog does. Well, it's a lot of data that you're moving, so that also has cost on the overhead. So this is what it looked like. I'm going to show it in a demo if the demo gods are with me. Anyway, this is the kind of output that you can get. So let's see. Let me show you a demo of all of this. Okay, this is an echo. Okay, fine. So let me try everything. Okay. So first of all, let me show you. Okay, Flame. This is the repo for my. Oh, you see that this did a lot of example. Okay. Now I have a few apps here. Let me show you. So this is an Express app with a few middlewares that does a few things. Okay, and I can run it with the Node CLI bin Flame. Okay, run. And I can do Express, okay? So it has started the thing. I can do some load testing, okay? So I can do, for example, these on the medium endpoint. Here we go. And this creates starting to get, does some load testing on it, okay? Just to create some load, so. Here we go. And then I can quit this. And we have some data being created. One is the flame graph, and then the other one is the heap. Okay? So this is the, now, the dim effect. Fantastic. You see? Why? Now. Okay, I'm opening up one of the existing ones, so I don't know why it's working, the demo gods. And yep, but let me do this. That might be it. Okay. Nope, no chance. Now, the heap one worked, the CPU one didn't. Good me. Okay, anyway, this is the heap one, the generic thing that you can see here. You can see where it's allocating the more data, okay? And at the top, you can see which is the function that is allocating the more data. Now, the function that is allocating the more data is medium computation. As you can see here, it's more or less what we would expect, to be honest, but we see exactly how much how much allocation has been done for each function, as you can see. So here at the bottom, you can see here it's allocated some stuff. Then we have a few others. This is the profiler. So now we can see also how much memory is the profiler being allocated, and so on and so forth. And there is, I don't know, some other interesting stuff that you can find. Now, let me see why this thing is not working. Good Lord. Yep, these are for whatever reason. Okay, I have a fix. Let me get you the fix. But, gosh, let me open it up. Let me open one that worked. Easy. Yep. So this is a profile that worked, and what I want, something else. Let me try another one. Come on, you see the demo gods. I dared the demo gods too much this time. So let me do this. And here we go. Okay. And these should do the trick. Okay, let's see. Nope, still. Back. Okay. Here we go. Go back here. This is the one without the flame graphs, the memory. So this is, you see, there's only one. And even this is not working. What? OK, I have no idea what's going on. And what is happening? OK, this is fantastic. I have no idea what's going on. It worked this morning, so I have no idea what's going on. And you can see this is what's going on. Why it's crashing? Like I've seen this error a few times, and OK. Anyway, yeah, bugs happen. Sorry, guys. So now. You can see here is another one that I generated before. Oh, this is the heap. OK, and here is the CPU. OK, this is another one that I created before. But even this one is now, everything is. A big int. OK, I have no idea. Good Lord. OK. Let me try something. npx add Platformatic flame at 1.0.0 generate this thing. OK. Yes. OK. I have time, so. Even this one is not. The mystery continues. I have no idea. Absolutely no idea. OK. Sorry for I wasted your time. I have, close too many things. So let me show you a few bits. So if you want to collect this information in our app, in an app, OK, you would do, you start that, and we need, this is just a basic React Node.js app, OK? It's just doing literally nothing. Web, OK, let me do this. Web. OK, this is just a basic app that just literally returns to string. We are using the latest Node strip types that you should be using. Yeah, no, I already started that. So here we go. OK, we have this is running. We can run autocannon. OK. Now we can start profiling. Sorry, made a mistake. OK. We can start profiling. Essentially, we can get the CPU profiling going, for example. And then, then I need 3042. OK, we can start the 3042. This is getting some load. And now this is there. OK, now I can stop, and I get the data. OK, this is. And then I will need to do the generate. But I have a right feeling that's not going to work, but I'm positive to try. I don't know why we're getting yep, wrong comment. Let me try a very early version. So flame. I've been using this every day for the last So let's try 013. So let's try that. Let's see if this works. Okay. Yeah, no, this worked. Okay. Sorry, guys. As you can see here, we got some interesting data. We can see, this is actually very interesting, to be honest, okay? So here you can see, we see as expected that the biggest chunk of time is spent in write-v, okay? And here you can see that write-v is getting that kind of information, okay? But we can also see some other interesting stuff, okay? For example, here, look at this block. What is this, okay? And if we open it up, this shows some t-digest. Now, that automatically embeds you a Prometheus server in it, okay? So you can automatically get the metrics out. And this comes exactly from that prom client, which, by the way, is not optimized at all. So I am working a little bit to fix that too. Hopefully coming out in the next few weeks. I have some work done that removes all these bottlenecks. But you can check it out and you see that there's a lot of things working here, for example, in t-digest, and a lot of things happening that is relatively costly. If you open up those things, you will see exactly what I talk about. It's pretty, this is what it is, okay? So you can see something interesting stuff, that this is even your metrics is costing you some time, okay? Even just collecting them, not even reading them, okay? And, this gives you a little bit of information, okay? Some other stuff that was interesting in the heap, okay? Recently, today, I did this check, of the heap, okay? And when looking at it, I found this block, okay? This is internal to our product, and this is a sanitize function. What is this doing, okay? And this morning, I did this PR to fix it, so you can see that the PR is actually there. And here we go. This is the PR that I did this morning to actually fix the problem, and it just changes that sanitize function into something more useful, okay? And it changes a lot of code. Anyway, just wanted to show you that how you can use it to quickly iterate into something. By the way, I feed this with Cloud Code, and now the tests are not passing, so you need to. But it's not because of Cloud Code, okay? It's literally nothing related to Cloud Code. It's some flaky tests, unfortunately. So here we go. Hey, we restarted things. Okay, so last but not least, I wanted to show you. Okay, this is the same error, by the way, that you were seeing before. Let me get it, okay? Last thing I wanted to show you is our control plane, the command center. Okay, this is an application. It's running a few services behind it. We can monitor things and so on and so forth. Important part, it has the autoscaler component that we showed before, okay? But also, you can have the flame graph things as I showed before. So here we go. This is running. This application running, okay? Let's go into autoscaler. I can start throwing some load into it, okay? So this application is available here. Nope. Where is it? Nope, this is this. Sorry, here we go. ICC. Sorry, I'm pretty bad. Now this is the other one. Okay, it's the leads daemon. Okay, this is the application. I have no internet. This is part of the problem, probably. Okay, next. Okay, this is the application. Okay, this is the application that I'm talking about. It's just a basic Next app that's doing some server-side rendering with some calls. Okay, I am going to throw it some load. Here we go. So now we are running some loads against it. Okay, and if I go here, these are my two pods. They will start receiving some. You see the ELU is going up. So it's starting to getting some load, okay? And here you can see that it's getting scale things up. And yeah, you see ELU is going up and so on and so forth, okay? Now, here you can also see that we are getting a flame graph up, but you got the same error that you got before, and I have no clue why. So it's, you see, this is the same error, the same begin error that I showed you before. I have someone earlier on that should probably be working. Here, nope. Still the same error, like I was fighting this before. And here, yeah, this one, it worked, okay? So anyway, this shows the exact same sanitized problem that I was showing before. So this is where I find it. So you can get what I mean, okay? Minus the begint bug, which I have no clue why it's happening, and we will fix the begint bug soon. This is it, okay? Thank you very much. I dared the demo god, that was our development version, and the demo god were not with me today. So, you know, it happens to everybody. Anyway, earlier this year, we have published this book about running Node.js in running Node.js. You can get it if you want. It's free. It's pay with your email, so we can spam you, and so on and so forth. So anyway, thank you very much, and I'm done. Thank you. This is another speaker, right? Straight away? I have probably time for a couple of questions, maybe, but it's probably there is another speaker starting immediately. No, you can go. Okay. If there are questions, very happy to take them. If not, you can go. You want to go?
No, you can go with the questions.
OK. Any questions at all? No, probably. Nope. Thank you, guys. Bye.